Let me introduce myself. First, I'm Dr. Umesh Dhamija, right? And as far as my qualification is concerned, I'm PhD in chemistry and MSc in chemistry, and I have been teaching for last 19 years, and have taught more than 70,000 students. Many of have cleared the IIT entrance examination and NEET also. So from Swahili University, I passed my PhD. In year 2000, I passed my MSc in chemistry. Right. And I had like some tie-up with Fiji and Akash, and currently I'm living in Ludhiana and providing some expert faculty with Drishti School and RS Model School, and also teaching as a master teacher with Vedanta. You might have heard about Vedanta.
Yeah, I've heard about it.
Okay, I have been working with them also, and so this is all about me. And now we start with the today's topic, right? And one thing more, that I am running one institute in chemistry like ChemZone, right? So this year, in this year JEE 2019 January, right? In my institute there were 60 students who appeared for JEE, and 20 have got more than 92 percentile. So this is all about me, and you told me that you want some discussion about the coordinate chemistry, right?
Right.
So should I start from the very beginning, or
yeah, let's start from the very beginning.
Okay, fine. So what is meant by the word coordination compound? Topically, just a minute. Wait. Yeah. Discussing about coordination complex compound. Can you see my screen clearly? I'm writing something on it.
Yeah, you just wrote coordination complex compound.
Right. So what is compound? You tell me something about what is meant by the word compound.
Well, compound is a molecule that is made up of atoms that come together either by molecular bonds or ionic bonds.
Okay. So compound is consisting of two or more elements in a definite ratio by mass.
Okay.
Right. This is a more appropriate definition. So I have shown here the water molecule, right? It is 2 grams of hydrogen and 18 grams of oxygen. So 16 milligrams, right?
Okay.
So it is 1:8. It's definite composition. Suppose I say carbon dioxide, then it is 12 grams of carbon and 30 grams of oxygen.
But then let's say I take a gas, I take a cylinder and I put in 16 grams of oxygen and 2 grams of hydrogen gas. It's in definite ratio, but is that a compound?
No, it's a mixture.
It's a mixture. So how do we know that based on the definition you gave me?
I told you. Compound is a unit of right, of a pure substance, right, in which two or more elements have some type of bonding.
Okay.
H and OH are bonded.
Okay.
Right, in a definite type of, and in that particular compound, 2 grams of hydrogen is combining with the 16 grams of oxygen.
Okay.
Right. Otherwise, this way will be just a mixture of the two.
Okay, I got it.
And now compound word is clear now, right? And now we talk about what is meant by the word complex compound. Complex word meant by the word complex. Can you tell me something about it?
Complex as a word just means something that is not complex, not simple, not simple.
Yeah, that's it. Very simple. Okay, so compound that is not simple is a complex. And what is complex? What is simple compound then? Which is not complex. Huh?
Okay.
Okay. Right. both the definitions are wrong actually.
Okay.
Okay, if I say iron exists as Fe2 positive or Fe3 positive, right? And if it makes bond equal to their charges, equal to their oxidation number, then we call this compound is a simple compound.
Okay.
Sodium has a valency of 1 and it is making one bond, so I say it is a simple compound. But if I say I have this compound K4FeCN6, right? Here iron is making bonds more than its normal valency or oxidation number. So this is making bonds more than its normal oxidation number. This is called as a complex compound.
Okay, so Fe is making 6 bonds here.
Yeah, it is making 6 cyanide-ion bonds.
Okay.
Right? So while making this bond, can you tell me what is the meaning of the coordinate bond?
No.
Okay, so suppose I say I have water molecule here. You know, lone pair of electrons are there.
Yeah.
And something like H positive attacks upon this. Then this pair is donated to the H positive ion.
Okay.
And by this way it has lost one electron and acquired a positive charge. So this bond formed between oxygen and hydrogen, in which sharing is between the two atoms, but donated by one atom only, that is oxygen. This bond is called as a coordinate bond.
Okay. So it is different from covalent bond in which both are sharing one electron.
Yeah. So this is the coordinate bond. So any complex compound in which this metal atom is making bond with this other things, which is called a ligand basically, and the bond between them is a coordinate bond, right?
Okay.
So this is called as a coordination complex compound.
Okay.
Right. I hope it's all clear now. What is the actual meaning of the word, the chapter name, coordination complex compound? Am I clear?
Yes. So there are also complex compounds that are not coordinate.
No. All the
complex compounds are coordinate.
Yeah, they will have metal and a ligand coordinate bond.
So complex is when the atom is making more bonds than its ionic number.
Yeah, oxidation number. Technically oxidation number.
Oxidation number. Okay. And coordinate is when when it's a metal atom is making coordinate bonds with ligands.
Yeah.
Okay.
So ligand is donating electron pair, but it is being shared between the metal and the ligand both.
Okay. Got it.
It is just like this. I give you my pen to write, but we are sharing it. We are using it both. Right.
Okay.
Right. Otherwise, what we do, you give me your eraser, I give you my pen. Right. Then we have a bonding between the two.
Okay.
Right.
Right. I got it.
Okay.
Okay.
You know, in our childhood, you know, in LKG, UKG, first, second, we used to do it like this. You give me your eraser, I will give you my pencil. that was the typical friendship bond. Right. So here they also friendship bond, but here donation from only one atom only.
Okay.
But
so it's one-sided.
Yeah, one-sided love. Okay. I hope you understand now, right? This complex.
Yeah.
So now coming to the bit thing which is part of the IIT now, right? IIT entrance test. It's a very introduction, right? And in IIT, first type of question that is expected is what is the name of the compound?
Okay.
Right.
Yeah. So naming.
Nomenclature. Right.
Okay.
So you might have done nomenclature of.
Yeah, I've done it. Yeah.
Okay. Can you name this compound if you know?
No, that might be hard.
Okay. Okay. So just your where are you located right now?
Currently, I'm in Rajasthan.
Okay.
I live near Ajmer, and before this I was in Kashmir actually.
Okay.
So I did my 12th from Kashmir, but so because my dad is in the army,
Okay.
So we keep moving around. But the teachers there were not good.
Hmm.
So my chemistry, I know a lot. I've covered the syllabus once, but my chemistry is sort of weak. It has a lot of holes.
Okay, no problem then. Then you're right place.
Hmm.
Then you're right place. Okay. The question that is generally asked, I'm coming to the topic right now, straight away. Wait a second. You know, my computer is full of chemistry.
Yeah, I see that.
Okay. So some basic thing, right? So here's the question, right? Coordination compound are mostly found by dash.
Okay. So I'm guessing not S and P. It has to be between D and F.
Yeah, it is only D block because in the empty D orbital of the element, they can donate electron pair, right? So answer is
B.
C.
Yeah, C. Okay, yeah, C.
So this is journal mistake that generally students commit in while filling the OMR sheet, right? Or this time you have electronic, so there also you have to fill the bubble. Yeah, click the bubble.
That can be confusing.
Yeah, that is here you have to be very, very careful. So there are certain compounds which are such coordination complex compound like chlorophyll, hemoglobin, vitamin B12. You might have heard these names.
Yeah.
So in these there are certain elements, metals are there.
There has to be iron in it, and I think cobalt as well. So all of these are the same option, right? No, okay. Hemoglobin should have Fe. I know that.
Yeah.
And chlorophyll should have.
Okay.
Yeah.
Chlorophyll is having magnesium, right? Hemoglobin has iron, and vitamin B12 is cobalt.
Okay.
So it is the B option correct answer. Okay. Okay. Just think about it and I will discuss in detail.
Okay, so I did ask this question, are all complex compounds coordinate? So
Not necessary.
okay.
Reason is, I told you here that this bond you can see I have drawn here. It is not a complex compound,
Okay.
but still it is having a coordinate bond.
Okay.
So another example I can give you. It is a ammonia, right? And has a lone pair of electrons. And here I have a BF that is deficient. And ammonia donates electron pair here. And this is a coordinate bond, but the resulting compound is not a coordination complex. It is not a coordination complex. Because the coordination complexes are typically formed when the element there is a D block element.
Yeah.
Got it?
Yeah.
So first statement is
Wrong.
Clear?
Yeah.
Complex gives ions in the solution. Yes, it may give, right? So first statement is correct, right? Rest all are correct statements. But our question is which is the incorrect.
Okay. So okay.
Okay, now come to this one.
The solution of complex in water. So I'm not familiar with these tests. So how can I know the answer?
Okay, fine. I'll tell the basic funda of this one, right? Basic funda is I gave you this complex in the beginning to name, right? If I dissolve this in water, it will give you potassium ion and this complex.
Yeah. Okay.
Right. So the ions which are present, they can be detected. It means the potassium ion can be detected.
Yeah.
But we don't have free iron ion or cyanidines.
Okay.
They are in the complex, they are not free, and they cannot be detected.
Okay.
But it may by suitable chemical test we cannot detect iron ion and cyanide in this complex. But potassium ion can be detected.
Okay.
Getting me?
Yeah.
So this is the basic idea.
Hmm.
Now, the question that was given to us was this.
Okay, so in that case, copper ions won't be detectable, but sulfate ions would be.
Yes, it means I'm not talking about which test is there right now. I'm not talking into analytical chemistry. I'm not doing that. But one is sure that if I go for testing of the sulfate ion, that will be detected, but the copper ions will not be detected.
Okay.
Ammonia will not be detected.
Yeah.
Those which are in this coordination sphere in the square bracket cannot be detected.
Okay.
Right. So come to this again, the same question.
So we can say that we'll give test of sulfate ions.
Yeah. Check which is the correct answer now.
Yeah, it should be C.
I hope you understand now.
Yeah, I do.
Okay. Now here is something now which is I have not discussed with you.
What is EDTA?
I will discuss it. I will discuss.
Okay.
Are you understanding my language?
Yeah.
Okay, fine. Now, in this complex, this is called as a central metal atom.
Okay.
And the one that is shown in this square bracket is called as a coordination sphere. And these which are in the common bracket with the metal atom, these are called as a ligand. And this metal atom and the ligand, they have a coordinate bond between the two. And if I separate them, I get here potassium ion and this one, right? So this complex has certain charge, 4 negative. Overall molecule is neutral, so here I have a 4 positive ion. So this ion which is outside the coordination sphere, it is called as a counter ion. So I'll be using these terms when I go in detail this chapter, right? Just introduction now, right now, of what is coordination complex compound. So coordination sphere and its counter ion. In this complex that we were discussing right now in a question, and tell me which is the complex and which is the counter ion.
Okay, so the complex is the counter ion is the sulfate ion, and the complex is the coordination sphere is of course the thing in square brackets.
Yeah.
The central metal atom is copper Cu, and the ligand is ammonia ion.
Right. This is very good now. It's a central metal atom, it's ligand. This is a counter ion, right?
Right.
Okay. So this ligand, I'm not talking about the ligand, can be either negatively charged, can be positively charged, can be neutral.
Okay.
Right.
Just needs to have a coordinate bond. Okay.
So if I say chloride ion and I draw its lowest dot structure, then I need to represent here the electrons also. Now how I have drawn the 8 electrons.
Yeah.
So these 4 pair of electrons are basically arranged at a tetrahedral angle. Getting me?
Yeah.
So towards a metal empty d orbital, is a metal empty d orbital. Can you read what I'm writing?
Yeah.
Okay. There is only one pair which can be donated. These cannot be, because they are not in that direction. They are not aligned in that direction. Only one is in that direction where the empty orbital is there. So this ligand is a monodentate ligand. Monodentate ligand are those which can donate only one pair of electrons to the central metal atom. Am I clear?
Yeah.
And we call this this ligand as a chloro or chlorido, right? Similarly, it can be bromo or bromido. It is a I negative. It can be called as an iodido or iodo, right?
Right.
C triple bond N, this has a negative charge here and lone pair here, but at a time it can either donate through the carbon or through the nitrogen, right? So this is again a monodentate ligand. We call this is a cyanido or cyano, right? Cyanido or cyano. Am I clear?
Yeah.
Then since it has two donor atoms, but at a time only one is operating, this type of ligand is called as an ambident ligand.
Ambident.
Yeah. Which has two donor atoms, two different donor atoms, but at a time only one can donate, either the carbon or the nitrogen. If it is donating through the carbon, we call cyanido, and if it is donating through the nitrogen side, we call isocyanido. Am I clear?
Yeah.
So if I give you this complex, right?
Right. So I can assume that since you have written the C first, it is bonding to C, carbon instead of nitrogen. So this would be that's silver.
So it is cyanido. The ligand is cyanido, right?
Yeah, cyanido silver.
No, nomenclature I'm not telling you the complete.
Okay.
It will take some time to discuss everything.
Okay, cyanido.
But if it is making bond with this one, right, with nitrogen, let it be. In that case, it will be isocyanide.
Yeah.
Right?
Right.
For this sulfur 2 negative, it is called as a sulfido. This is also monodentate. SO4 2 negative is sulfato. SO3 2 negative is the sulfito. S2O3 2 negative is thiosulfato. You have to remember this, right? Because in our complex, these ligands will be appearing, so you should recognize it and give a name. OH negative is hydroxo. O2 negative is oxo. 2 1 negative is superoxo. Getting me?
Yeah.
And O2 with a 2 negative is peroxo. And now you might have studied this particular molecule in your +2 basic classes. Can you tell me what the name of this compound?
I've seen it, but I don't remember. This is what COO die. No, I don't know.
Okay, this compound is called an oxalic acid.
Okay, yeah, oxalic acid.
And if they lose this one H positive ion, you can find here that this is like this. It can donate electron pair from 2 donor atom to the metal atom, and this is a bidentate ligand.
Okay.
Right, and this ligand is called as an oxalato. Right, it's a bidentate ligand. Monodentate ligands are those which can donate only one pair of electron to the metal atom. Bidentate are those which can donate 2 donor electrons to the metal atom. Right. If any group, any molecule donate 3 electron pair, then it will be called as a tridentate ligand. Right? See this molecule. So this metal atom it is donating pair of electrons, right? 3.
Yeah.
So there are 3 donor atoms to this metal atom, right? So this is a tridentate ligand. Can you name this compound, this ligand?
No.
It means your organic nomenclature is also not so good. Okay. Diethylene triamine. Diethylene triamine. You can see that 2 ethylene groups are there and 3 nitrogen are there. It's a diethylene triamine, right? Okay. Now, this structure, the simple structure that I am right now drawing here, I'm calling it simple structure, but you might be thinking it is a big one. Huh? Actually, it is not so big, it is a very simple one. Only we have to understand it step by step. This part is called ethylene.
Okay.
There are 2 nitrogen here. So it is ethylene diamine. And this part is the acetato part. Diethylene, ethylene and diamine, tetraacetato. Tetra because there are 4 in number. So it is a E for ethylene, T for diamine, T for tetra, A for acetato. EDTA is this one.
Okay.
Got it? And with this metal ion, these 2 nitrogen atom can donate electron pair to the metal atom. And 4 acetato oxygen can donate electron pair. 1, 2, 3 and 4. So total number of bonds, coordinate bond, it can make is equal to 6, and it is called an hexadentate ligand.
Okay.
Right. So EDTA has donor atom nitrogen and oxygen both. There are 2 nitrogen and 4 oxygen, right? Now coming to the same question where we left. Yes.
Okay, 4O.
Yeah, 4 oxygen and 2 nitrogen. Means second option I can say it is the correct one with one spelling mistake.
Yeah.
Okay. And leave this question, of course. And in this case, you can see that this chromium is making 6 bonds with the water molecule. 6 water molecule. It is a wrong representation here. This water molecule should be outside. This 6 should be outside, right? It means chromium is making 6 coordinate bonds with the water molecule. So how many bonds it is making? 6, and that is called as its coordination number.
Okay.
Coordination number means how many coordinate bonds are formed. Yeah, I think this question I have already discussed with you.
In ambident ligand is one which has a C, has 2 donor atoms, but either of the 2 form a coordinate bond.
Okay, nomenclature I have not discussed with you right now, right? After this talk we have the topic of nomenclature.